this afternoon.
We've got a new one, John.
All right. Well, welcome everybody to the IRM podcast. It's another Friday. Welcome. It is, what is today? The 3rd. Oh no. It's the evil March 3rd. 3-3. Yes, sir. 3-3. Today's 3-3. Everybody wearing orange?
Yeah, somewhere on my shirt, I'm sure there's orange.
Yeah, they got
What have we got today?
Oh, today, hour 1, we are breaking down 4 questions. Around Twitter, there's been this little meme that's been passed around by believers in the spinny ball, asking flat earthers 4 questions about gravity. So today we're going to address that because I just keep seeing it pop up and pop up and pop up. It never really addressed, and it's being used as some sort of end-all be-all conversation killer for flat earthers. So we're going to go ahead and break down these questions. So the next time you see this meme pop up, you can just paste a link to this show and we'll address it for you. My name is Josh. I'm from Missouri. And this is Iron Realm. Everybody want to give themselves another introduction?
I'll start.
Sure, this is Walt. Oh, go ahead. Sorry.
You got in there first, Walt. Off you go, bro.
You go, sir.
I'm not
Adam.
Okay. Good evening. Good evening. My name's Adam. I'm from Nottingham, England.
Hi, Adam.
Cool, Walt.
And I am Walt, here in South Louisiana. Hi, all.
Hello, everybody. My name is James, the Full Armor OG. I'm in Chile, Canada, and I hope you enjoy the show today. We've also got a wonderful segment on some gyroscope stuff with our very own John Savage, and we hope you all enjoy it.
With that, John, go ahead and introduce yourself.
Yeah, just John Savage from the UK.
That'll do. Yeah, as James said, Glowbuster featured John's gyroscope video, and there's been some subsequent criticisms about his experimentation. So he's addressed those in another experiment, and we're going to kind of break down the criticisms and go over this new experiment and see what's what. So yeah, that's it. So I thought we might as well go ahead and get started with these silly 4 questions. This stuff,
I don't put them up.
Yes, I believe we can.
Cool.
I may even zoom in a little.
Do you want to read the first one?
Yeah, let me zoom in so everybody can see. There, maybe that's a little better.
Yep.
So this was the meme that was passed around. The Flat Earth Challenge. 4 simple questions. Question 1 was, why does an object, when dropped, fall towards the center of the Earth at an acceleration of 9.8 meters per second squared? Number 2 is, if I drop an object while standing on the top of Mount Everest 1 meter from the ground, and then drop the same object 1 meter from the ground at sea level, will they both accelerate at 9.8 meters per second squared? Number 3, if I have a vacuum chamber and place an object in the middle, which direction will it move, if at all? And number 4 is, if I drop a ball of gold and one of aluminum, both having an equal radius, i.e. equal volumes from the same height, simultaneously, will they hit the ground at the same time? And if so, why? Now, just to get this out of the way, I'm counting more question marks than 4, but I'll let that one pass.
Thank you. I am a grammar Nazi. Go ahead.
So yeah, we took a look at these and we kind of thought it'd be fun to just break them down and give at least, well, we may not even get one cohesive answer, because that's the thing about Iron Realm. You see there's 5 of us in here. We're missing Rob. Rob's busy working.
Shout out to Rob.
Shout out.
Shout out, brother.
Rob.
So should be 6 of us, but that would be 6 theoretically what could be different theories as to what's going on here. So we may not all agree. We're 6 people from all over the plane.
Well, you know, Rob will agree with anything we say. He'll just go, yeah, you guys are absolutely 100% correct. That's his way of doing it.
As always, I'll just defer to you guys. That's it.
Right. So let's get into the first question here, guys.
Yeah, let's jump right in.
Yeah, I'm excited.
Who
I'll
wants to
start.
take a first stab at it? Anybody?
I'm going to have a stab at the question, first of all.
All right, let's do that.
So, the first question, I think it's full of assumptions, so it's hard to answer the question, first of all. But so, why does an object fall to the center of the Earth? Well, how do we know it's falling to the center of the Earth? Who's got a center of the Earth ometer? Is the first thing I'd ask. So you can measure that it's falling to the center of the Earth. I don't think that exists. But what I do think we can ask of the question, maybe it should is why does an object fall straight down? Because we can see that it's repeatable, it's observable, it's testable, falsifiable. So we can test that. What we can't test or follow is an assumption. Firstly, from my point, that we know where the center of the Earth is. It's a falsehood in the question. But if we worked with why does an object fall straight down in a straight line, then I think that's probably...
I'm having a bit of trouble hearing Adam. I don't know if it's just my connection that I'm already having trouble with, or are you guys having trouble?
No, you're a bit quiet, Adam.
A bit low.
Yeah,
That's a first. That's a first thing. Is that
there
better?
you go, brother.
Better.
Excellent.
That's
Thanks,
a bit
Walt.
better.
There you go.
So what you're saying,
so
you're saying that basically there's an assumption to the very beginning of the question is that there is a center of the Earth.
Right.
Yeah. It's the question, to be perfectly frank, the question is unscientific in of itself because it's starting with an assumption.
Can we
If
bung the
at all-
question back up again?
We can. I just wanted to point this real quick out here.
Yeah,
This
go for it, Josh.
is Occam's razor. And it's often confused with the principle of parsimony, but Occam's razor is just that a theory that makes the fewest assumptions is most likely the correct one, which is really similar to parsimony, which is the simplest explanation is often the correct one, and they're very related. But right here with Occam's razor, if we start dissecting these questions with Occam's razor, we can almost throw the first one out offhand because it's already based on these assumptions.
Yeah, it can't be answered without sort of agreeing with the assumptions that the question's being made.
And I should also point out that when we address gravity, what we mean is what is causing objects to fall down.
Not
We're
what
not
is causing planets to rotate around stars millions of miles away.
Well, we don't dispute that what goes up must come down, right? Things are going to fall
Absolutely.
down.
They do.
I agree.
Drop
That much
a
we.
pencil, idiot.
So when we say we don't agree with gravity,
I think-
it's not that we think things are going to float away.
Oops, sorry. I
disagree.
just dropped my mic. Sorry, Carrie. Sorry, carry on.
No, that's it. That's all I had to say, really. We
Perfect, sir.
agree things fall down. We agree.
Cool.
But only on a flat Earth is there down. There ain't no up on a ball. FYI.
Are you seeing the group chat? You
Shoot. No, this is usually Rob's forte.
okay? No. I didn't mean the live chat. The actual group chat.
I'm getting it back up.
Okay, cool. I have a very short memory.
Hello, everyone. I'm back.
Hi, back.
I'm back.
See?
John, you mess around with NDS or ND, whatever his initials are, NDT, and that's
Yeah.
what happened.
I didn't do anything of the sort. I simply
You got
dropped
us
my
scared.
microphone.
Right. You weren't
So why does an object when
mocking
falling?
King Scientism.
Adam, have you done away with that one?
Well, I've done that. That was my first
I've got a
of
little
the question.
point on that one too. And this again, we're like Josh says, we're totally different blokes here, right? But for me, I have a hard time like taking anything serious when they're talking about the center of the Earth, because I mean, if you look at it from a common sense or from an Occam's razor point of view, we can only drill so far down and we can only do so much. So I really have a hard time of talking about any journey to the center of the Earth, whether it's an object falling or whether people want to claim anything about the center of the Earth, because they just have no clue. So
well, you've seen the Jawbreaker model picture. You know it's true because it was in a book. Come on, James, get it together.
That's how molten metal works. You got to get it really, really, really hot for it to hold a magnetic charge. That's how that shit works.
It's called the Curry
It's
temperature, isn't it? It's a certain temperature of metal where, or ferrous material becomes non-magnetic with temperature rises. So it makes the center of the Earth a magnetic molten nickel core or whatever, an absolute farce, because it can't be repeated on the Earth.
Nope. Never can you liquefy metal to that degree and still have it magnetic properties. It just doesn't happen.
Yeah. So if we take out center of the Earth and we're left with, why does an object, when dropped, fall down? We'll put down in there, or to your feet.
Yeah.
At an acceleration of 9.8 meters per second. Now, do we know that it does drop to the floor at 9.8 meters per second?
Or to refer to Adam's second, Adam was mentioning something about, what's that guy's name? Adam Richard something?
His name's Richard Sheldrake. So
Rupert.
Is it Rupert Sheldrake? Rupert, yeah, sorry. Excuse me. Yeah. And he's a qualified, respected scientist that questions science in a very scientific way. And I think Josh has got some, maybe a picture of some of the statements that basically shows that we assume gravity is a constant. It isn't, neither over time of short time periods or long periods. And I think it states in there's a 1.1% variance, which isn't very constant. And the other thing it states is that the that's measured is 40 times greater than calculated. So it's well outside of the error range of measurements.
What can you just make that a little understandable again? What did you say? It's four times?
So it's so when the scientists observed, so scientists have commented on these obscure results. There's a 1.1% variance, and in doing so, they look at it and wonder why the hell there's such a variance. Gravity is a constant. So they go back to calculations to see, well, what kind of variance could we expect? And what they're saying is that the variance that is measured is 40 times greater than what see through scientific error, measurement error.
Wow.
Instrument error. So there is not, so the point being, scientifically, as proven by scientists, gravity is not a constant. As for greater detail, I would refer to Mr. Sheldrake.
Go ahead, Walt. Thanks,
Well,
Adam.
as far as that, that whole idea of the observational, we were talking about the core a while ago. The whole theory of the iron ball, chewy nougat around it type idea is because of seismic waves that are supposedly bouncing back off this impenetrable.
Yes, this woman. Yep, she wrote a theory on it. There was actually a woman. Yep.
So I mean, you take that and lay it out into a flat area with layers, and that there's different layers, different densities, different layers of magnetism. However we put this realm machine together, I mean, that would fit into that whole idea of observe it one way with an assumption of a ball. You put it into a big nickel nugget in the center. You assume that it's a plane and fit it into layers. So
I'd like to chime in and say, probably need that. Yeah, there we go. Josh, you're sharing the Rupert Sheldrake article there. Is there any nuggets in there that he's saying other than he's got a book, the measured values continually change, and I show it in my book. He did a great presentation at the Ted Turner conference, TED Talks or whatever it was, explaining how the gravitational constant is constantly changing, and they're constantly changing the official figure for it. And didn't they do a study, Adam, where they were testing it throughout the different
There
times
we
of the
go. It's
day?
coming up. Yeah, it's just coming up now. Look, if you look, so 73 to 2010 shows you that the bits I was quoting.
That's pretty
There we
interesting.
go. Difference between recent high and low.
Yeah, what's at the lowest average for the gravitational value of gravity was 6.66. 6.59, I mean.
Yeah.
Right. We just added one more to that list. We're the highest.
There's 3 there already.
I find that funny that gravity, the average value of gravity is 6.66, just to
The lowest
bring
average.
that up.
Yeah.
But
Get the numerologists on that one.
and John, just wanted to say, and this comes from a layman guy, so even me, because I'm not scientifically bound, but that science holds fast to that 9.8 m squared. Because we've just kind of taken that down a bit, and now I'm looking at the second question, and it's again based on that whole true 9.8. And I'm under the idea that if it's science, real science, like tested, verifiable, provable, we shouldn't be able to do these things. But it seems lately, as you guys may have seen when Bill Nye was actually put on the spot, a lot of them maybe don't really know the science or the true nature of the work underneath the values that they've had to memorize and learn over the years.
That was a great video you made, James.
And I will say that of all the people I saw passing this around, not once did I see them offer any answers to these 4 questions. They weren't open their mouth and put their money where their mouth is and say, well, here are the answers. What did you come up with?
I haven't seen any answers to those questions either yet.
I think that's the point, guys. If you research, and you know, there is a massive difference of opinion, even on some of the upcoming questions within the scientific community. Different explanations, different reasons, different causes for things we see. Opposition of what we're supposedly seeing. Some people say things drop. Do you know what I mean? The same, some pay they drop differently. Do you know? There's a massive amount of opposing thought, and therefore spurious explanations within this official scientific community. And I think from the research I did, it was totally.
So can we get those questions back up again so we can just see?
Yeah, let's go for number 2 if we're ready.
I mean, let's try and answer number 1 if we can get past that, because I mean, we haven't really offered anything. I mean, I'd like to put on the table electrostatic force. Anyone done any research on that?
Yeah.
Earth being a giant battery and there being static enough.
I think save that.
We all
for
came up with that
question
idea
4.
in one of these chats like 2 years ago, wasn't it, John? You and I and Mike was in the group, James, all this whole crew.
Salt system, and
that this was a big battery that we're in. I think that was before the whole realm quote even got tossed around in the mix.
Possibly, yeah. Okay, we'll move on then. Yeah,
guys. Save that. No, save that for question 4, because that is the crux of question 4. As it's the crux of it. So we'll save it for.
Cool. Take it away then, Adam. Number 2.
Yeah. Josh, it's your turn to read. Just
read it again.
2. Yeah, let's have it.
If I drop an object while standing on the top of Mount Everest, 1 meter from the ground, and then drop the same object 1 meter from the ground at sea level, will they both acceleration at 9.8 meters per second squared?
No. It's the only one I give an answer to, and I can validate that with the reasons we've just said, and then some that you just alluded to. And the basic one is air density. If you look at some of the discrepancies in terms of why scientists argue there's differences in results, air density is one of the ones that's agreed upon, and the effects of air on. So I would suggest that there is sufficient air difference that if you're going to go past the 1 decimal place that we're using there, that you would see possible observable differences
I
by
agree.
scientists.
I agree, and it makes sense, doesn't it? If there's a less dense atmosphere at the top of Mount Everest or whatever, let's say it's 5 miles up, so there would be less resistance, an object falling. The resistance would be
It's less.
less,
It's less
surely.
thick soup.
So it would surely fall slightly faster. I haven't seen this experiment being done, so I'm only speculating. But what I can say, I would say is, with skydivers, these record-breaking skydivers jumping out of balloons and things, they get up to incredible speeds coming down when they first jump out. I mean, if we can accept or assume that the Bumgardner jump was for real, then he got up to crazy speeds before slowing down as he got further into the Earth's atmosphere. I just seem to remember that from that video that he was sort of doing, something possibly nearly 300 miles an hour or something, and then was slowing down because terminal velocity, they tell us, isn't it 125 miles an hour or something? Don't they claim that's the maximum speed you can fall at?
I thought it
That
was
sounds right, but we can Google it.
Oh
I-
yeah, that's a good idea. I've got too many windows open here.
Yeah, so do I. And didn't he almost
I'm
pass
looking. Hang on.
consciousness or something as he was coming down?
Yeah, yeah. And also when he jumped out, there was almost no movement or ruffling in his clothes, in his suit. And then as he got lower and lower and lower into the atmosphere, you started seeing his suit, really starting to ruffle and look as though it was going 100, 120, 130 mile an hour or whatever it was. So yeah, I would say things fall faster and then get slower as they get into more and more dense atmosphere.
Mhm.
That makes sense.
We'll
But
see.
there's the whole problem with it all, because no matter what you do and no matter what we say about the air density and all, their whole hat hinges on the fact that everything is where the gravitational force is proportional to the center of the Earth, which we have a problem with. So already I'm annoyed. Anyways, carry on.
So let's
Yeah.
move on to this elusive vacuum chamber that we can't create.
That's the answer that I got. Guys, you're going to laugh when you see what I got when I Googled it. First thing that came up.
What's that?
Go look at the picture I dropped in the Hangout chat room.
Joking. I can't.
Well, while we're looking at that, I mean, my point to this question is, I don't even know what the question's on about. It's not actually very clear to me what they were talking about specifically. If you have a vacuum chamber and place an object in the middle, is that in the middle on the floor?
That's what I wanted to know.
Are you levitating it in the middle of the chamber and wondering what's happened? So I wasn't really sure what the question was alluding to in terms of, because obviously if it's on the floor, nothing's going to happen. If you're levitating it magically in the middle
How?
and then you let it go via magnetics, whatever, I don't understand. I didn't really understand the question.
No.
The only assumption I made was the feather hammer experiment that we see in vacuum chambers, which I'm happy to have a stab at.
Yeah, we'll have a go at that in a minute.
But-
Let's just see what
that is
the
a show in
terminal
itself,
velocity
isn't it?
is. What's the graphic up now then?
Ultimately, it's from NASA and talking about terminal velocity. This is from the John Glenn Research Center? Glenn Research Center.
Mm.
Blah blah blah. I see lots of equations, but they're going to break it down for us. Very bottom line in bright red: objects do not fall at the same rate through the atmosphere.
Objects do
Okay.
not fall at the same rate.
So I mean, there we go. We could just stop the debate, right?
So objects do fall at different rates through the atmosphere. Okay, fair enough.
And
Gotta be
that's
done. There you go. NASA.
basically due to size and grav. If you look at the equations, look, the drag equation, force equals drag minus, what's W? Weight. Yeah. So drag's quite a big component in all of this. And the shape of the thing is the is the deciding factor in this. Not, yeah. Weight plays a part, and we'll talk about that later, which is quite interesting. Because weight's not supposed to, is it? But it's there. Drag minus weight. But weight, you see, is opposing the other way in this equation, isn't it? It's saying, actually, the net force down is drag minus the weight. So it's postulating that the weight of the object has a positive impact on its downward force. And it's slowed by the drag. So that's interesting on question 4 again. But we'll come to that. Because the drag in the same on question 4 is 0, isn't it? We'll come back to it.
Yeah, can we have the questions back up again?
So this is the nonsense. Yeah, the vacuum chamber question, wasn't it?
Oh, that's right. Yeah, it was just needs clarifying. What are you hanging it in the middle? Are you lying it on the ground? Or I didn't understand. You know, they obviously think. I don't quite know what they think because they haven't provided any of their own answers to these questions.
Dead square middle of the chamber with finite dimension, and we just center it in every
sort of levitating there.
Correct.
Levitating? That's how they meant it, kind of like the feather thing, do we think?
Okay, well, if that's the case, then it would just fall down to the ground.
Right. But I guess if you place an object in the vacuum chamber, you'd have to place it and then evacuate all the air out. Right. That's
so like Adam said, with some sort of gravity mechanism, ring gravity or some not gravity, magnet holding this thing in place in the middle of the vacuum as it's getting expelled of air, and then the magnets are turned off. What will happen to it? It will fall to the ground.
Yeah, but it's an awful lot of stuff that's not in the question.
Yeah, well, yeah, exactly. So it's
and then you place an object. I guess it doesn't even say you have to evacuate the air out of the chamber and create a vacuum. You just have to have the chamber. Technically,
kind of alludes to what I was saying. I mean, we've seen this type of stuff go around the memes, and it gets passed around. But I would wager a fairly, I think, confident guess that a lot of the people sending this stuff around really don't know exactly what it is or how to write it, because they would have changed the questions to reflect that. So anyways, moving on.
Yeah, I think we kind of answered that one. Let's go to number 4. If I drop a ball of gold and one of aluminum, both having an equal radius or equal volumes from the same height simultaneously, will they hit the ground at the same time? If so, why?
So if we look at that equation, which is lovely, it would suggest no, wouldn't it? Because the net force down is equivalent to the drag minus the weight. Now, we know that the gold ball, it weighs a lot more. Yeah. And that the drag should be the same for both of them.
Correct.
So the net force down. So we can ignore the drag equation. So the net force down, drag, so the force is D minus W. Put simply, isn't it? So it's going to have it's a negative thing because it is going down. I'm assuming that's why it's written like that. Yeah.
Are we accepting this NASA formula?
I'm assuming our question posers would. So let's just work with it. Is what I would say. I don't think there's a reason to doubt it. I'm not well versed enough in it to question it, but just based on that assumption, there are in those three that equation there, the force equals D minus W. D we know is the same for both balls, and W we know is different. So will that mean we get a different number on the other side? F? Yes, I suppose is the answer from NASA.
I think Walt is performing some online
testing
experiments.
Yes, way to go, brother.
You got goggles on. Because they did this, didn't they? They did it on the What Happened on the Moon documentary that we have. You got that, Josh? Do you remember we lined up them doing the experiment in the studio in 1G?
I can find it.
Oh, that was a good one.
So this is the bit that relates to the gravitational. So what is causing it in it? Where they
I'm
claim.
gonna do one in slow mo. Give me a few minutes.
See if you can have Quentin hold it down a little bit lower.
So
It was
what were you
about
saying there, Adam?
2 hours in.
So what? This is the interesting part. I really do need to read those equations a lot better because they can't make any sense. Because if the force down is equal to d minus w, and if the drag in a vacuum chamber is 0, then the weight is the only thing that means a net force down. And we see in the vacuum chambers, whether you believe in gravity or electromagnetic universe, then they fall roughly at the same time. There's not a W of a difference, to put simply. So I'm not sure what those equations really mean. There must be something more in it. When drag is equal to weight, then there is no net force on the rocket. Fair enough.
I thought it was a pretty simple equation myself, right? It's just drag minus weight, right?
Yeah.
Hmm.
I think it's more of a statement than an equation, an explaining statement than an equation. But the principles you can see are true in it. But I don't necessarily think it works like that.
Every time I've done it, when I've done this myself
No.
and dropped weights of different densities, they hit the ground at the same time. But then I'm not, I'm only doing it from a meter or whatever. I'm not doing it off the Tower of Pisa with slow-mo, full frame, 60 frame per minute camera watching it. But that should be all over the internet, shouldn't it? I mean,
Well, that's what I was going to say, John. That not to get conspiratorial, it's kind of like one of them gerund things where you go to the South Pole and there's no 24. There will be experiments out. I've done for such what would be simple stuff. You would expect to see out there all sorts of tables, a ball of this size, this size, this size, for anything. And it's stuff that would help you derive logic, and that's probably why it's not there in a usable form.
But the only one I saw, I mean, you put one up a couple of days ago, didn't you? And it was that Oriental kid dropping two paper balls off his stairs. I mean, where are the university students or whatever, these ones that are launching balloons all over the place? Where are these guys, dropping something off the faculty building and having it filmed as part of a science experiment to prove or disprove what this is? I mean, maybe they're out there, I don't know, but they should be littered. This should be known, surely.
That's what I said. There wasn't a plethora of evidence just for you to easily pull the sort of stuff you'd expect. If you're researching medical stuff, right?
It's a lot more
it's
complex.
there. They're basics of stuff like that. But this is shit falling. It's not hard to measure. Stopwatch, job done. Somebody's done it. It's not even there as a falsified set of anything. There's nothing there, James. It's really strange.
No, but I mean, if you're gonna
find it.
If you're going to look at the topic, what I would say is you would start with, free fall air resistance. You would start looking at acceleration of gravity, free fall motion, Newton's second law, stuff like that. Like we can actually, put together the stuff's there, like you're saying, for us to actually put something together. I can see something proper. There should be, but if there isn't, I can see what we need to do to put something proper.
Okay, well let's use what we have been given, right? So what we were given, what we were told, and have been implanted in our heads is that when they dropped a hammer and a feather on the moon, they both landed on the ground at the same time, and therefore that proved they were in a vacuum. So we've got that footage here. Is this it, Josh? Where they recreated it in a London studio?
It
and
is.
It did exactly. So can we have a look at that?
But this is them supposedly on the moon.
So that we could see it was not the same fakery as the first time.
That's them making it up, isn't it? They're not claiming they're on the moon. This is the real moon footage. Real.
Doesn't in any way prove that it had taken place on the moon. Before NASA reenacted.
Yeah, you can do that anywhere.
We had
Hold on, Jones.
our own experiment. Here we are in our London studio in 1G, complete with an atmosphere, and without the benefit of a vacuum chamber. There they go. As you can see, The feather and the hammer arrive on the ground at the same time. Down by the appropriate amount. Lo and behold, these two items fall nice and slowly as per a 1/6 G environment.
All right, I'd pause it there. So does that not show us straight off an experiment that anyone can do to any degree they want to do, to take it to any degree of dropping a hammer and a feather from a meter or from 500 meters or whatever, that disproves what we were told, what we grew up being told was the thing on the moon, saying this proves we're in a vacuum. So that just proves it's rubbish, doesn't it?
Well, absolutely.
It doesn't. It doesn't prove anything either way scientifically. It proves we're being lied to, is what it proves. You know what I mean? That's the.
Well, one of them
the thing,
claimed
Scott.
to be in a vacuum, but was probably in a London studio. The other one claimed to be in a London studio and probably was in a London studio. But either way, we can test the London studio one. We can't test the moon one. And we don't have to, because we've just seen it land in the London studio at the same time. So it clearly doesn't prove it's in a bleeding vacuum.
Yeah. Let's not even get into vacuum, because then we have to talk about how atmosphere ends and the vacuum begins. And that is so ridiculous. Why I don't have the patience. I don't know. It's a joke, that one.
Unless the one in the studio is a fake, and then therefore, like I say, you're being lied to. All it shows is you're being lied to. So you can prove which one is false. It doesn't tell you who's lying to you.
Yeah, but one of them can be tested and one of them can't.
Yeah, exactly. So until you test it, which is what we're good at, which we'll do,
yeah.
You know what I mean? You can't tell who's lying to you. But what that does show you is that somebody is lying to you.
Yeah.
We can test it. Now, can I just make one interjection? I was looking at those equations, and the force is upwards. It's talking about net force, so it's drag minus weight, yeah, and it's talking net force upwards against gravity, I think. But I don't make any statements on those equations till I've had a proper chance to read them, because 5 seconds I've just thought I think it's the other way around.
And they're from NASA.
Talking about, yeah. I think it's talking about opposing force to the fall of gravity is what he's talking about, what it applies against gravity.
Am I the only one that thought that there was a maximum terminal velocity?
No, we're told there's a maximum terminal velocity.
That is, terminal is the highest one, isn't it? Terminal velocity, that's like all things fall to that, apparently.
Yeah, that's what I thought. So I'm not the only one who was told that if you drop something from any height, that it will reach a certain speed and won't get any faster. That's what I was told, or how I understand it.
Mm-hmm. And I would support that, because that's how I was told too. And I was told that even objects that encounter air resistance always ultimately reach the terminal velocity too, which is the end. They all do, right?
So do they not? Yeah. So did they not tell us what the terminal? So I mean, that's an equation about terminal velocity that says on the bottom that different things fall at different rates. But do they ever get to the point where they tell us what this terminal velocity is?
No, but I think the point from those equations is the terminal velocity is created by the atmosphere, the density of the air, and the effect upon the effect of air currents upon the object, which is why drag is in the equation, because the shape of the object quickly you can reach that terminal velocity.
But that would suggest that each object has its own terminal velocity.
Each object will have a different rate of achieving terminal velocity. So an arrow will achieve terminal velocity, yeah. But eventually, the density of the air limits the speed to this terminal velocity, is my understanding of it.
So it's ridiculous to say that there is a terminal velocity when there is, numerous atmospheric pressures all over from wherever you drop this thing. Have an aeroplane on top of Pisa or whatever. Isn't it ridiculous to say that there's an expression called terminal velocity?
Yeah,
especially
I would suggest it's a non-constant constant.
Absolutely, because every time
it's very rarely achieved.
Another one.
Altitudes changes it by 1 or 2%. It can. Altitude very much so affects all these things. It's all based on different things. I think you're right, John, because it's
Wow.
like it's like if we're dropping it all through these different densities and stuff, and they're all reaching a same thing, but that thing is different because of the density and the
Yeah, spot on,
height.
James. Spot
It's
on.
really hard to say that there is a TV and a definite one. It's
see.
an indefinite formula for determining it in the density of the atmosphere where you're at specifically.
So it's just theory on theory on theory. It's pointless, really.
Yeah, and with
Yeah,
what we do
I
as a
agree.
group, it's really hard to listen to any of this crap anymore, because I just want to be able to put it in a way where I can get off my stool and test it, because that's how science is going to end up being in our age. People are sick of the lies. They're sick of this complicated formulas. They're sick of being excluded of it. And I think people actually really want to do something and learn. So we got to
Well,
do away with these
I
bloody
think that
equations.
segues quite nicely onto the next topic, doesn't it?
Yeah, have we hit hour one? We've got about 15 minutes left, I think.
15 minutes left.
Well, Josh,
I've
did you
got-
want to
Did I make it
introduce
back for the hour?
I've-
Okay, good.
Oh yeah, dude.
We got a lot of people in chat saying we're ignoring them.
We are.
Yes.
I because we haven't got Rob here.
Yeah.
I will
What's
log
wrong?
on right
Who's
now.
in chat? Let us know. Who's in chat? What's going on? I was
Oh,
about to
I could
crack a
probably get it
joke
on my
saying maybe we
computer,
should
maybe.
ask chat. I didn't know anyone was in there.
Oh yeah,
I
we got
didn't know.
Who can read it? Who can read?
I'm so used to Rob handling it, I didn't even look. Yep.
Yep, I'm on it.
You got it? All right. So I
Rob,
said,
we
well,
miss
since I'm
you.
not here with,
Well, Josh, you're reading it. Surely you just told us.
I miss you guys this week. It's been a bad week for me, but I'm back.
Oh, we lost.
So while I
did
was
we
out there, I
lose?
decided to go ahead and do it right. So I sent a couple of videos to the chat. They should be uploading here in a second.
all right.
I mean, the live attempt was pretty all right, I guess, but we'll see what happens with the
Can you see
more
the chat
scientific
there,
approach.
Josh?
I can. Yeah, it's basically saying, I mean, not a whole lot, basically just going through it as we are, explaining that, okay, I guess every object has its own terminal velocity, and terminal velocity is kind of a constant that just kind of depends on a different number of factors. So it kind of varies what that constant is going to be. Yeah, even
Shout outs
mm,
to who's in there.
let's see. Sure, we can shout out to everybody. We have Paper
Well, I
Explanator.
think we've done this gravity to death probably by now. It's if we've still got 15 minutes to go or whatever.
I mean,
I think I'd say that what it does show is that all of these questions, all of them, are nonsensical in as a proof for gravity. They demonstrate the action of a force. They provide no validity for the nature of that force. They just simply describe an effect of that force, which is something that, unlike electromagnetic theory, which has at least a postulation, is demonstrable or measurable. With gravity, that's repeatable, other than if I drop something, it falls. Look.
And there's nothing in there in this force that doesn't disagree with the properties of density and buoyancy.
Good point, John.
And I think NASA's just showed that for us, that certainly on the plane we live in, not a vacuum chamber, the biggest variant is the shape of the object and the weight of the object.
The surface area, yeah, absolutely.
Just to see the difference in those things.
And the properties of the medium that the object is falling through.
Yeah,
absolutely.
Hence why Felix slowed down, because he got thicker. The soup got thicker, so he had to slow down because he reached his terminal velocity early on, and as he got.
But see, doesn't this all just kind of make you scratch your heads and go, okay, so science is so definite and definite, but yet 6 of us here sitting around on our Friday show have just shown quite clearly that it's theory on top of theory based on variations, based on locations, based on density. But yet when the people spouting this and the quick answers to this when they're challenging you is, well, it's 9.8, it's 9.8, it's 9.8, and that's the way it is, and you don't know otherwise. It's very, I'm enjoying this. It's nice.
I still want to know who's in chat.
We have got Cara Diane, Thank you for listening. We've got Lone Zen Warrior. We've got Paper Explainer. We've got
Hello.
Curved Water and Jared Buto. Sorry to screw up the name. It seems like we've got a couple ballers, a lot of flats, and a lot of people today. So
Any
excellent.
comments
Yeah,
from the
Thanks for listening,
ballers?
guys.
nice amount.
Say again.
Sorry, guys. Any comments from the ballers? Have you got anything of
Just
other than
how much
or
Wow.
we need an education. But
As I'm logging into my YouTube to try to give some of this, I'm noticing we are actually up against a couple of competing shows right now that are running live. Antonio Subarats is running a live Flat Earth show, and Nathan Oakley is
Excellent.
running a live show at the moment. So
Well,
considering the
shout out.
competition, we're not doing bad. So
Good
Shout
timing.
out to those guys, and shout out to everybody that
hi
is.
guys?
Shout out to everybody that is actually rolling up their sleeves and getting this
doing the
going.
job. That's what's up. Getting it out there.
It's coming on, man. This movement is getting bigger and bigger, and it has been so exciting to watch it develop. I mean, we had it's been a little quiet this week, hey guys, but last week we had that Kyrie Irving come out. We had
Wow, we could join up with these guys. We would have a huge show right now.
we have some other engineers and pilots. I've heard word that some military people in Australia have been calling in, some engineers. There's a lot of good buzz around it, and it's been very exciting to see the media's reactions, the mainstream reactions, and I think for me personally, I got a really big boost when I watched that Bill Nye interview. If anybody of our listeners haven't seen it, it is a gentleman on Fox.
Tucker
What was
Carlson.
his name again? Yeah,
Tucker Carlson,
and
Carlson
he-
or Carlson or something. Destroyed
Yeah.
it. It was hilarious.
but he wasn't trying
With
to.
no science.
He wasn't trying to. He was literally trying to have a fair, open debate. And I run into that when I actually say to anybody in real life about Flat Earth, they end up getting, really defensive. And if I say, okay, well, let's just break down the basics. Okay, so you believe that the Earth is rotating at X amount, and that we are rotating, and you just start with that, and they're like, I'm not even going to debate these facts. These are hard science. This is proven. Like, you're ridiculous, and that's what we're going to see more of. Like, Bill Nye was really nervous. He should be the nervous guy. But anyways, I don't want to get on a bashing rant, but it's an exciting time for where we are and what we're revealing. So I'm just happy to be on board, and shouts out to Antonio and everybody else running a show. Let's just keep getting the message out there.
Can I say that, actually, guys? Antonio and Nathan are both guys that I've reached out via emails and tweets and G plus, on vids and that, and to little effect. Again, guys, get in touch. It'd be great to talk to you. Great to kind of share some thoughts with you as well. Yeah, another shout out there, guys. Get in touch.
yeah, I just wanted to point out to Cara Diane again that we don't deny gravity. Flat earthers don't deny gravity. This refers back to cause and effect. We don't deny that things fall. We're questioning the cause, not the effect.
I don't use the word gravity because it's a made up word for something that was already understood and used long before the magic of gravity came up. Gravity is not just dropping a mic, though, is it? It's how we don't career into the sun. It's how we don't career away from the sun. It's how the moon doesn't crash into us. It answers. I mean, gravity is because the moon rotates around the Earth. Why doesn't the moon rotate around the sun? And why? Do you see what I mean?
Saw a little clip on that tonight, John, actually, another bullshit explanation, and it was quite interesting because it relates to Jaron saying they can only do small amounts, one, maybe two solar bodies in terms of gravitational effect. And he had the gravitational bubble of the Earth, right? And with the moon rotating within it as it went around around the gravitational bubble of the Earth was so strong as it went around the sun. It didn't change it in any way, shape, or form. The moon just moved around on the same pattern, even though it's claiming there's two sets of gravitational forces being applied. The moon supposedly follows a perfect circle. It's so weak when you just try to look at it other than being shown a pile of calculations instructed to, of course, prove that they equal something. That's the skill of manipulating formulas and stuff. That doesn't mean it works in reality. It means it works on paper.
And then you got people like balls out physics, going through the math. What was it he was trying to work out? I think it was he covered gravity itself, and the formula basically cancelled out mass.
Yeah, weight. Yeah.
And he was just like scratching his head. I mean, he's an engineer, a civil engineer, or I don't know what sort.
There's a lot of them coming out, John. A lot of these high level people.
Yeah, plenty. There's no shortage of academics that are flat earthers, but of course, one by one, they can be dismissed by ballers just as crackpots, like Dr. Wakefield or whatever. If and when they unite together as a force, then then we can have something.
Bring back the round table, then we can do the IRM round tables and maybe have some intelligent discussions with some of them that have put together ideas and have been able to break the cognitive dissonance and the anger and the disdain for the fact that we may have a point and we're not nutbags. So
the thing is, James, we've got we all know on Iron Realm that we've got in the sidelines, we've got pilots, we've got engineers, we've got gyroscope technicians, we've got PhD
military people, we've got even magnetic theorists in our group. We've got math minds, we've got business minds, we've got blue collar minds. We don't really seem to get nervous anymore with the comments, because one of the things that we as a group and me and as an individual have learned is that time is our friend. Time is on our side.
Oh yeah.
Because once people actually start to look and they can really break through the fear of looking stupid, of not fitting in, of maybe wasting their money on an education, when they actually stop and go out and start doing the field work and looking at this in a non-biased way, which I hate to bring up Fox again. He said, listen, Bill, this is just what I'm doing. I'm just asking normal questions. Isn't that what science is? Let's figure it out. Let's test something. I'm willing to say yes if you're right. Like, let's look at this together. But we just don't have that with the ball people yet. But I'm hoping, if we continue our message in a proper, intelligent manner, like we strive to, that it'll happen. Anyways,
James, I would say that again. You hit a good point, and these 4 questions came in, guys, and I didn't know how to answer them because I'm not an expert in everything. And to answer something, if you want an chance to read, and I think that's the thing. We're expected to answer everything instantly, like there's some encyclopedic device, because we claim the Earth is flat. We should know everything about everything instantly. And the only thing I would say is don't be afraid to take a question on, but never answer it instantly unless you are confident in the answer. And the thing that's come out of this few days, just having a quick read now, is that question on, it strengthens your resolve and your opinion in the flat Earth. Because if you read past the first Google headline and the search and go into what's actually being said and analyze what's being said, you come up with what we guys have come up with tonight, which is not necessarily answers, but more questions and certainly more disproofs than you started with.
You said far more diplomatically than I would, and that's why I'm on Twitter, because I want to actually go and research the answer before I come back and answer it like an arse. But I hold to the position that if you're a rational, reasonable, intelligent person, and you research flat Earth with an unbiased, open mind, that you can't be a ball earther anymore. And if you still are, it just means you haven't researched it enough.
It is. It's so true. Once you actually, like, we're not idiots here. To the listeners, we're normal people with normal lives. We're your brother. We're your friend. We're the guy that works in the lab with you. We're not. Just take a real look at it. That's all I would say. Just like Adam said.
Flat Earth is like any other science. When I was a young scientist, I was lucky enough to dispense a prescription for a guy called Stockley, and he writes. I think this book must be about 3,000 pages. It comes out every year, and it's basically drug interactions. And he lived. I have connection with Nottingham Uni, and he lives nearby. And I ended up dispensing his prescription. And I remember just asking him a few questions. I said, "How do you know all this stuff? How do you?" He says, "I don't. Everything. What you have to do is put stuff together and have people who are trained and intelligent enough to be able to read factual data and come to their own conclusions. Science is, son," he said, going out there, reading the information and coming to your own conclusion. And if you read, this guy is about, is it safe to use this medicine, this person with these medicines? He never says it's safe ever. What he says to you, these are all the cases of what's happened. Have a look at your patient and you decide. Yeah, but he gives you the evidence. He never tells you what to do. He is same with flat Earth.
And do you see that as a cop out and go, "Oh, come on, I haven't got time to look at the evidence. Just tell me."
To me, everybody out there that believes in the globe Earth is telling you what to do. Do this, and I'm not telling anybody what to do. But I'm saying, go out there and research. Just read yourself. If you see a statement, ask why do you believe that statement.
It's like those on the street interviews with that guy up in Scotland.
Yeah.
Just asking such simple questions, and people just sat there scratching their head, going,
Because most of the stuff assumption. Look at our pondering points, lacks of knowledge tonight, and the reason we've not got lacks of knowledge, we can answer the questions. Why? Because we've never bothered to think why before, other than when these things come in. But as soon as you do, like I say, it doesn't weaken you, strengthens it. If you bother to apply yourself and research, read it.
It absolutely does. It absolutely does. And Josh, I believe, sir, we have finished the first hour.
We are right up on it. Yeah, that was,
what's
that was
the
4
procedure
questions.
now?
I'll just say to Rob, that, my son, is a segue.
Bam!
So what do people have to do if anyone's watching now? Do they have to change rooms or anything, or what's going on?
Well, if you just keep an eye out there on our YouTube channel, we are going to pop the next room up for the next hour, just right behind it. Hopefully I can do it relatively quickly. In the second hour, we're going to be discussing John's gyroscope video, the one that they showed on Globebusters, and there's been a couple debunking videos trying to critique it and criticize it and go over it. John's made a few adjustments and has put out a new gyroscope video just moments ago, fresh off the presses. So in hour 2, we're going to start a new room. So if you guys want to jump over to a new chat room, that's where we'll be dissecting this gyroscope video.
Thanks, everybody, for sharing what you said. I enjoyed it. Bye.
I'm so glad. Thanks, everybody, for joining and listening to the Iron Realm. And hopefully we'll catch you in hour 2.
And chat guys, come on over with us. We're enjoying the chat. Thanks.
Yeah, we'll see you in hour 2. As soon as I get a link. Where do mere mortals like me go?
It should drop in one of the rooms for us here.
Okay, no worries. Catch you later.
Josh.
See you later, guys. Take care.
All right, we'll see you in a minute. Oh, and that video I did of the hammer drop with the feather is still processing in this room. You'll be able to show it still later.
Cool.
All right. Awesome.
All right.